Hello, this is Maths with Lemon, and now we'll see some IB past paper questions on complex numbers. Now, you have to understand that many problems with the complex numbers, they include geometry. It's very easy to solve complex problems using geometry. Now, let's see this problem. It has 3 questions, but I will show it one by one. Let z1 be this one, 2 square root 3, is 7 pi over 12, z3 2 is theta, and z2 is z1 plus z3. Be represented by the points A, B, C on an argand diagram as shown below. Now, the shape of ABC is a rectangle. Show that theta is pi over 12. So I want basically theta. Now we will break it down one by one so as to see what I'm dealing with. They ask me the angle of theta. Now the angle theta is basically the argument of z3 complex number. We know that all the complex numbers can be written in Cartesian form. Now, how can I find this angle? Basically, here you can see I have a rectangle. They say also it is a rectangle. Important. Now, I'm taking my data and I see that I know exactly the form of z1. z1 is 2 square root 3 cos 7 pi over 12 plus I sine 7 pi over 12. Now I see that they give me the argument of z1 and it's 7 pi over 12. So basically they tell me that this angle here is 7 pi over 12. What do I know though? What I can see very clearly, that the angle AOC here, it's a right angle because I have what? A rectangle. So basically, if I will subtract from my from the argument of z1 my 90 degrees, I will have theta. So basically, angle theta will be 7 pi over 12 minus 90 degrees is pi over 2. So basically it is pi over 12. 6 pi over 12, so it is pi over 12. Easy question, but using geometry, very useful, the geometric knowledge in these questions. Let's see the next question. Find now the argument of z1 minus z2. Now, how I solve these kind of problems? When I have to find a calculation between z1, z2, z3 or whatever, not multiplication, not division, but addition or subtraction, it's easy, since I don't have anything here to tackle with, it's easy to simply use geometry. Now what does it mean z? First, if I want to find the complex number z1 minus z2, this is z1, this is z2, so as to find it, I should do what? I should work with vectors. If I have a vector, let's say here a, and I have a vector, this is a, and I have a vector b, how much is a plus b? A plus b is, if I take my vector and I put it at the end of A. So A plus B, basically it's this vector, A plus B. Now, what happens if I have A minus B? It's very easy. This is B, so how much is going to be minus B? Minus B is going to be exactly the opposite here. So now I do the same process. I go at the end of A and I bring my B vector. So how much is AB? A minus B? This one, A minus B. Exactly the same method I will use for this problem. So this is Z1 and I want to add the opposite of Z2, minus Z2. So what should I do? Easily, this is Z2, so I will, let me make it exactly the same. This is Z2. So basically I will move my Z2 where? At the end of A with opposite direction. That's minus Z2. So which is basically the my vector Z1 minus Z2 is this vector here, Z1 minus Z2. And they will ask me how much is this angle, the argument of this. Basically wrong. They ask me how much is the argument from the x-axis moving clockwise. As you can see now, this argument is the whole straight line pi plus this small angle, which is, it happens to be the same angle with Z3, the argument of Z3. These are opposite sides. So basically what I have is that the argument of Z1 minus Z2 will be pi plus pi over 12, the argument of Z3, which is 13 pi over 12. Very geometry helps a lot again. Now let me do the next question, which is, let me bring it here, exactly here. The question is, express we have a small issue here. It's the question. Let me put it here down. So the question is, express Z2 in modulus argument. Wait. Now express Z2 in modulus argument. Now I know that Z1 is 2 square root 3 cos 7 pi over 12 plus I sine theta 7 pi over 12. I know that Z3 argument is not argument, the complex number in polar form, 2 cos pi over 12 from the first question plus I sine pi over 12. Now, first of all, I need to find, basically Z2 will be R, which is the modulus of Z, cos theta plus I sine theta. Now, let's find the modulus of Z2. Now, to find the modulus of this, basically the magnitude of this vector, it's easy because I know Z1, which is this side here. I know Z3, so I can use the Pythagorean Theorem so as to find Z2, since this is a right angled triangle. So how much is my values using the Pythagorean Theorem? The magnitude of Z1 is this one squared, 2 square root 3 squared, plus the magnitude of Z3, which is 2 square, which is 4 times 3 plus 4, which is 16. So basically, so now I know that Z2, the magnitude is square root of 16, which is 4. So I know that Z2 is 4 times cos theta plus I sine theta. Now the only thing is to find the argument. So here I know that Z3 is the magnitude of Z3 is 2, the modulus of Z3 is 2 square root 3, and the magnitude of this is 2 square root 3, and the magnitude of Z2 is 4. So easily again on this right angle triangle I can calculate the cos theta, which is going to be the adjacent 2 over 4, the hypotenuse. So cos theta is 1 over 2, and theta is going to be, using the inverse of the angle, I know that is pi over 3. Yes, it is pi over 3. Now, since we know that the argument is pi over 3, I know that angle theta is pi over 3. Now, the argument of my Z2, basically here I should not put theta. Theta is this angle, but the argument of the Z2 should be from the x-axis. So I need this. This is the argument of Z. So basically it's going to be theta plus theta 1, let's call it, plus this, the argument of Z3. So my my angle, let's have a new page, my angle is going to be, my theta angle is going to be pi over 3 plus pi over 12, which is going to be 5 pi over 12. So how I can write now my Z in a modulus argument form, basically in the form of cis, it's going to be Z equals the modulus, which is 4, times cos 5 pi over 12 plus I sine pi over 12, and in a compact form cis 5 pi over 12.